Now, this is our third video on graphing rational functions. In this video, we are looking at two other categories, the last two categories of rational functions. Last time we observed that some rational functions have the degree of the numerator smaller than the degree of the denominator, and we talked about those. This time we have functions where the degree of the numerator and the degree of the denominator are the same. And then we have functions where the degree of the numerator is larger than the degree of the denominator. So these two will complete the discussion of all three categories of graphing rational functions. Alright, we're still going to find all four important things: the x-intercepts, the y-intercepts, the vertical asymptotes, and a horizontal asymptote if we have it. Alright, so in this one, my x-intercept, remember I only have to look at the numerator for that. So I say 0 equals 2 minus 5x. Well, that means that x equals, I can move the 5x over, so I have 5x equals 2, and then x equals 2/5. So my x-intercept for this graph is 2/5, 0. Now, to get the y-intercept, I'll let x be 0. Well, if x is 0, then those two go away, and I have 2 over 1, which is 2. So 0, 2 is my y-intercept. My vertical asymptote always comes from the denominator. It's what makes the denominator equal to 0. Here, if I said 2x plus 1 equal to 0, then I get x is equal to -1/2. So this is my vertical asymptote. My horizontal asymptote for functions in this category, where the degree of the numerator is the same as the degree of the denominator, my horizontal asymptote is made from the ratio of the leading coefficients. So if I look at my expression here, my leading coefficient in the numerator is -5. It's not the number that comes first. The leading coefficient of any polynomial function is the number in front of the highest degree term. Well, the highest degree term is x, and the number in front is -5. So I have a ratio of -5, that's the leading coefficient in the numerator, to the leading coefficient in the denominator. The leading coefficient in the denominator is 2. So my horizontal asymptote, excuse me, that should be a y, is y equals -5/2. All right, well, I'm ready to graph this function, okay? And I'm looking at my horizontal and vertical asymptotes as I sketch my axes here. Right, so first I'll go ahead and graph my intercept. So 2/5, 0, somewhere around there, and 0, 2, well, that's right there. And then my vertical asymptote is x equals -1/2. Well, that's going to be right here. And then my horizontal asymptote is y equals -5/2, or -2 1/2. And that's going to be right here. Now, my curve has to hug my asymptotes. So I got these two intercepts I have to go through. So this curve on this side then is going to come along here and hug this asymptote on this side and hug the asymptote on this side. There's many times symmetry with these rational functions, so I know that if the graph over here is in this quadrant of my asymptotes, then the other part of my graph is going to be here. Now, if you need to pick some points to prove that to yourself, then just go right ahead. But we understand that this curve is going to be here. Now, this looks like the parent graph curves for 1 over x. And in fact, if you divide this and change it into a mixed rational expression, a mixed number form of a rational expression, then you will have a variation on the 1 over x family of curves. All right, well, let's talk about this one. This is the third category of rational functions where the degree of the numerator is larger than the degree of the denominator. First, we'll get our x-intercepts, y-intercepts, vertical asymptotes, and then we're going to have a discussion about the horizontal asymptote. Right, my x-intercept, I only need to look at the numerator. Well, that numerator can be factored, all right? So if I factor the numerator, all right, so really I've got that, well, I'll move these down. I've got that 0 equals x plus 3, x minus 1. So I can see that my two x-intercepts, I've got two of them, and it's negative 3 and 1. So my x-intercepts are, I think I've got some room right here, negative 3, 0, and 1, 0. I have two of those, okay? My y-intercept, I'm going to let my x is equal 0. If x equals 0, then my y-intercept is negative 3. So x is 0, y-intercept is negative 3. Now, the denominator is x plus 1, and that's where we get the vertical asymptote. So the denominator will be 0 when x equals negative 1, therefore x equals negative 1 is a vertical asymptote. All right, functions in this category have no horizontal asymptote. We can go ahead and write horizontal asymptote, and there's not one. That's because there's going to be either a slant or an oblique asymptote. Now, what we're going to do to get that asymptote is divide. Because I'm just going to divide it up like I'm turning it into a mixed number. All right? Now, I can do long division. All right? That's perfectly fine. Or I can do synthetic division to get that slant asymptote. Since I've got this set up, I'll go ahead and do long division. X goes into x squared, x times. So I have x squared when I multiply, and then plus x. And when I subtract, then 2 minus 1 is x minus 3. X goes into x one time. All right, so we don't care about finishing out the problem. We don't care about the remainder. What we do care about is the quotient. So I have a slant asymptote, and the equation is y equals x plus 1. Now, if the degree of the numerator and the degree of the denominator differ by more than 1, then you could have a parabolic asymptote, or you could have a cubic asymptote. But here we're just having a slant asymptote, and that's all we're going to discuss. So let's go ahead and graph this. All right, and let's see, x plus 1, x equals negative 1. All right, well, I think we're pretty good right here. All right, so here's my x equals negative 1 vertical asymptote. Remember, we never cross the vertical asymptotes with our graphs. And then my slant asymptote it's a line, but it's got a slope other than 1. Now, this is not doing a very good job here on my graph, so it's going to be a little hard to get that just right, which of course is easier if you have graph paper. Alright, so y-intercept is 1, my slope is 1, so I'll just kind of get me some ideas of some points here. I'm going to go through now. Really, I would use a ruler, but since we're just kind of getting the idea here, I'm just going to draw that through here. I'll make this a little more realistic. So there's my slanted asymptote. Now, I know that 0, negative 3 is a y-intercept. Negative 3 and 1, there's negative 3 for x, here's 1, are x-intercepts. Well, from my intercepts, I can tell what my curve is going to look like. On this side, on the right side of my vertical asymptote, remember that my curve is going to hug these asymptotes, so it's going to have to come down through here like this on this side. All right, and on the other side of my vertical asymptote, that vertical asymptote kind of divides the graph into two parts. On the other side, I know that I have to go through this point. Therefore, when I get to the right of this point, I'm going to have to hug this asymptote. Now, it's a little bit curvier than I want it. I'm going to have to hug this asymptote, and then I'm going to have to hug this asymptote. So my curve is really going to come down like this and do like that. And there is my rational function in the third category.